This is AP Precalculus. We're in the review phase for our AP test using the three-peat activities. This is activity K. In number 1, we have a quadratic function, and we're trying to find what the second value is. What is this value of n? So because we know we have a quadratic value, it even tells us this term. Normally, I would not expect this to be listed because it's one of those properties you're supposed to memorize, but our second differences are all the same value. They are constant. So here's what that looks like on a table. If I look over here, I'm going to first look at the first differences. The first differences are how much have I changed between 2 to 3? Well, I've added 1, and from 3 to 2, I've subtracted 1, and from 6 to 13, or from -6 to -13, I have subtracted 7. That's going to be helpful in a sec. Now I'm going to look at the second differences. The second differences is how fast or how much are the first differences changing? Well, to get from 1 to -1, I had to go down 2. And because all of these differences have to be the exact same, I know that in order to get from this difference and this difference that I don't know, but this difference to -7, I also had to go down 2, to go down 2, and to go down 2. All of these second differences must be the same. They are a constant number because this is a quadratic function. Those properties go hand in hand. If I have second differences that are all the same, it implies we are a quadratic function, and vice versa. If I have a quadratic function, it implies all my second differences are the same or constant. Because I know that this value to get from here to -7, I had to subtract 2. I can go backwards and I can add 2 to get -5. Maybe I should use a different color here. I can say that was supposed to be black, -5. And I know I can go backwards again. I can add another 2 and I get -3. And you can check. To get from 1 to -1, you subtract 2, you subtract 2, you subtract 2, you subtract 2. Everything here is working correctly. And then finally I can say, okay, well, that's the first difference now. In order to get from 2 to the next value, I must go down 3. 2 minus 3 is -1, and the correct answer here is -1. The correct answer is B. All right, moving on to number 2. We have two functions, without a calculator, but they're pretty straightforward. So I want to find the point of intersection. Intersection means we're setting one function equal to the other, and we're solving for x. All right, so my first function is 5 to the power of 3x plus 2. The second function is 25 to the power of x. We are solving for x. This is slightly an easier problem because we don't have to actually use exponentiation or anything like that when we have our exponent trapped up here in the power, because we can try to get similar bases. That's the first strategy you should try to get. If this is a 5 and this is a 5, if the bases are the same, then I can just set their powers equal to one another. So on this right-hand side, I can transform the 25 into a base of 5 if I simply square it. This is going to be 5 to the power of 2, therefore to the power of x. The left-hand side has not changed. I'll just copy and paste that one in a second. And notice that this is the same thing as 5 to the power of 2x, because when I have a power to a power using properties of exponents, you just multiply them together. And this is still equal to the left side, which we have not changed. Let's go ahead and copy and paste that over and over again. So I have same value and same value. From here, now that I know that the bases are the same, the only way for me to have an equal to sign is if the powers are also the same. So I can make another set of equations. Let's move all these over to give me some more room. You guys move right there. And I can say, well, that means that 3x plus 2, the power of the left, needs to be equal to the power of the right, 2x. And then from here, I'm going to, you can solve this a few different ways. I'm going to subtract 3x on both sides, subtract 3x, and that's going to give us 2 is equal to -x. Divide both sides by -1, or you can multiply by -1, whatever floats your boat or sinks your sub on this one. And that's going to give the negative away, leaving behind the x is equal to a -2. The correct answer here is a -2, or letter A. And then finally, for the third and final unit of this curriculum, we have a sinusoidal function, and we're just trying to match the graph with our equation. So this graph, I am going to use each of these parts. I'm noticing in the options down here, it goes 1, 2, 3, 4. It kind of, all of these half periods and quarter periods are all the exact same. So this pi over 2 is going to be meaningless to us in terms of how these graphs are all related. Let's go ahead one at a time. So if I have a 3 out front, a number out front is implying that the amplitude is 3, or the distance from the midline is 3. I'm noticing that the midline is here. I go up 1, 2, 3. The midline is here. I go up 1, 2, 3. The midline is here. I go up 1, 2, 3. The midline is here. I go up 1. Well, this one is incorrect because it has an amplitude of 1 instead of 3. Okay, next, I see that that one is not going to affect us. Next, I have a sine function. A sine function implies we are starting at a midline, whereas a cosine function would start at an extreme, like a minimum or a maximum. Because we have a sine function, should be starting the midline. Starts the midline, good. Starts the midline, good. Starts at the maximum. That is a cosine function. That is incorrect. Just be careful. Sometimes you have phase shift in here, adding or subtracting on the inside. Phase shift will affect where you start your period. Essentially do the opposite of whatever is happening on the inside and move that direction as your new start. Finally, to decide between options A and C, we look at our last number, the -1, which affects the midline. How far up and down is that midline shifting? You don't do anything opposite. If it says -1, we go down 1. This midline is at +1. This midline is at -1. We needed to go to -1. The correct answer here, therefore, is C. And that does conclude our 3-peat K activity. Thank you for watching.